Hello everyone, and welcome to our first lecture in Module 03, Computer Science and Security. Today's lecture is titled Foundations of Programming, and I am delighted to have you all here as we begin our journey into the world of computer programming. Over the next hour or so, we are going to explore what programming truly is, why it is such an essential skill in today's technology-driven world, and how computers interpret the instructions we write. We will focus specifically on Python, a language renowned for its simplicity and versatility, making it an excellent choice for beginners and experienced programmers alike. Let's begin by discussing the concept of programming. At its core, programming is the art of communicating with computers. Think of a computer as a highly obedient servant that can execute complex tasks if given precise instructions. These instructions are written in programming languages, which are structured forms of communication designed to be understood by both humans and machines. The process of writing these instructions is known as coding. When you write code, you are essentially crafting a set of steps that the computer follows to solve a problem or perform a task. In today's digital age, programming is everywhere. From the smartphones we use daily to the complex systems that run our financial institutions and healthcare systems, programming underpins all of the technology that drives our modern society. Understanding how to program opens up a world of possibilities. It empowers you to build software, automate repetitive tasks, analyze data, and even create innovative solutions to real-world problems. In this lecture, we will primarily use Python as our tool of exploration. Python is widely recognized for its readability and clean syntax, which makes it an ideal language for beginners. Its simplicity does not come at the expense of power, however, as Python is used in fields as diverse as web development, scientific computing, and artificial intelligence. By choosing Python, we are setting the stage for a smooth introduction to programming fundamentals. Let's move on now to one of the most important building blocks of any programming language: variables. A variable is like a container in which we store data. Just as you might use a box to store items in your home, a variable is used in programming to hold information. This information could be a number, text, or even more complex data structures. In our discussions today, we will use the term variable to refer to these storage units that hold the values our programs need to function. Imagine you are writing a program that needs to remember a person's name. In plain language, you might say, "Let the person's name be stored here." In programming terms, you would create a variable and assign the person's name to that variable. This process is fundamental to nearly every program you will ever write, and understanding it is crucial. Next, let's consider the different types of data that we can store in these variables. Data comes in various forms, and programming languages have a concept known as data types to help us manage these forms effectively. In Python and many other languages, we encounter several primary data types. The most common types include strings, integers, floats, and booleans. A string is simply a sequence of characters, like a word or a sentence. When you store a person's name in a variable, you are typically using a string. Integers are whole numbers, such as 3, 42, or -7, while floats are numbers with decimal points, like 3.14 or 0.001. Finally, booleans are data types that represent one of two values, true or false. They are often used to control the flow of a program by making decisions based on certain conditions. It is important to note that every piece of data you store in a program is associated with one of these data types. This association helps the computer know how to interpret the value and perform the correct operations on it. For instance, if you try to perform arithmetic operations on strings, the computer will not understand your intentions in the same way it would with numbers. Now that we have discussed variables and data types, let's talk about how we use them to perform operations in a program. In programming, operations are performed using what we call operators. Operators are symbols that tell the computer to perform a specific calculation or comparison. There are several categories of operators, but today we will focus on three main types: arithmetic operators, comparison operators, and logical operators. Arithmetic operators are the tools that let us perform mathematical calculations. They include symbols such as plus, minus, multiply, and divide. For example, if you wanted to add two numbers together, you would use the addition operator. While I won't show you too much code here, you can imagine that in Python, you might write something that tells the computer to add two numbers stored in variables. The simplicity of arithmetic operators makes them accessible and powerful for a wide range of applications. Comparison operators, on the other hand, are used when you need to compare values. They allow us to check whether one value is greater than, less than, or equal to another value. These operators are crucial when making decisions within a program. For example, if you need to decide whether a person's age is above a certain threshold, you would use a comparison operator to check this condition. The outcome of such a comparison is a Boolean value either true or false, which then helps guide the flow of your program. Logical operators are used to combine multiple conditions. They help you build more complex decision-making structures by allowing you to say, for instance, execute this action if both condition A and condition B are true, or execute this action if either condition A or condition B is true. Logical operators are the glue that holds together multiple conditions, making your code more flexible and dynamic. It is also essential to understand how operators work together in an expression. In programming, an expression is a combination of variables, operators, and values that results in another value. Just as in mathematics, where you follow the order of operations to solve an expression, programming languages also have rules that determine the order in which operations are carried out. This order of precedence ensures that expressions are evaluated correctly, and understanding it is vital to writing correct programs. Now that we have covered the theory behind programming, variables, data types, and operators, let's discuss the practical side of things. One of the most effective ways to learn programming is by doing. Throughout this lecture, I encourage you to actively engage with the material. As you listen, try to visualize how you might use these concepts in a simple Python program. Imagine writing a line of code that asks for your name, then storing that name in a variable, and finally printing out a greeting message. Although I am not including extensive code examples here, this thought exercise is fundamental. It helps to connect the abstract ideas with real-world applications. Let's take a moment to reflect on what we have covered so far. Programming is essentially about giving instructions to a computer. We do this by writing code in a language that the computer can understand. Python is one of those languages, known for its clear and readable syntax. The building blocks of any program are variables, which store data, and data types, which tell the computer how to interpret that data. To manipulate this data, we use operators, which perform arithmetic, make comparisons, and combine conditions. I want to emphasize that understanding these fundamentals is crucial. When you learn the basics, you set a strong foundation for all the more advanced topics you will encounter later in your studies. Even if you never become a professional programmer, these skills can help you think logically, solve problems efficiently, and approach complex challenges in a structured way. Before we move further, let's consider a few everyday examples. Imagine you are planning a birthday party. You might start by writing down the names of all the guests. In a programming context, this is similar to storing names in a variable or a list of variables. Next, you might need to decide on the number of chairs, the amount of food, or the time to start the party. Each of these decisions involves numbers, integers, floats, or even booleans if you are simply deciding yes or no. And, much like how you might add up the total cost of all the supplies you need, arithmetic operators in Python allow you to perform similar calculations with ease. By thinking of these everyday activities in programming terms, you begin to see that coding is not an alien concept. It is a logical extension of the way we organize and make decisions in our daily lives. This realization is empowering because it shows that anyone, regardless of background, can learn to code. The process may seem challenging at first, but with practice and persistence, the principles become second nature. Now, I would like to delve a bit deeper into Python as a programming language. Python has become one of the most popular languages in the world because it prioritizes readability and simplicity. The language was designed with the idea that code should be written in a way that is easy for humans to read. This philosophy, often encapsulated by the phrase readability counts, means that when you write Python code, you are encouraged to use clear and descriptive variable names and straightforward syntax. For instance, consider the process of asking for a user's input. In Python, you might normally use a function that prompts the user and stores their response in a variable. While I won't delve into the specific code details, the key takeaway is that Python makes it easy to interact with users and manipulate the data they provide. This simplicity not only speeds up the learning process but also makes Python an excellent tool for rapid prototyping and development. As we continue through this lecture, keep in mind that the concepts you are learning today are the stepping stones to more advanced topics. The next lectures will build upon these fundamentals, introducing control flow structures like conditionals and loops that enable you to write more dynamic and powerful programs. But today, our focus is on ensuring that you have a solid understanding of the very basics. Now, let's summarize the main points we have discussed so far. First, we learned that programming is the practice of writing instructions for computers to perform specific tasks. These instructions are written in programming languages, and Python is one such language known for its clarity and simplicity. Next, we examine variables, which are the storage units in programming. Variables allow you to hold data such as names, numbers, and other values. We also discussed data types, which categorize the kind of information a variable can hold. Finally, we explored the role of operators, arithmetic, comparison, and logical in performing calculations, making decisions, and evaluating expressions. To reinforce these concepts, I encourage you to think about practical scenarios where you could apply what you have learned today. For example, try imagining a simple application where you ask someone for their name and then greet them by name. Or think about how you might compare two numbers to decide which one is larger. These mental exercises are invaluable in solidifying your understanding of the material. Before we conclude this lecture, let's briefly discuss some common challenges that new programmers face. One frequent issue is confusion about data types. It is not uncommon for beginners to mix up strings and numbers, which can lead to errors when performing arithmetic operations. To avoid this, always be mindful of the type of data you are working with and remember that converting data from one type to another is a routine task in programming. Another challenge is understanding the flow of a program, especially when multiple operations are combined in a single expression. Learning the rules of operator precedence, knowing which operations are performed first, will help you avoid logical errors in your code. As you continue to practice, these challenges will become easier to manage. Each mistake is a learning opportunity, and every error message you encounter is a clue that helps you improve your programming skills. The key is to remain patient, persistent, and curious. To wrap up today's lecture, I want to reiterate that the fundamentals of programming, variables, data types, and operators, are the building blocks upon which all other programming concepts are constructed. Mastering these basics will not only prepare you for more advanced topics like control flow and loops, but will also give you the confidence to explore and create your own programs. In our next session, we will dive deeper into control flow structures, where we will learn how to use conditionals and loops to make decisions and repeat actions within a program. For now, I encourage you to review today's material, ask questions if anything is unclear, and perhaps try a small exercise on your own. Even if you simply imagine how you would greet a friend using Python, every bit of practice will help you build a stronger foundation. Thank you for your attention and engagement during this lecture. I hope that you now have a better understanding of what programming is, why Python is a great language to start with, and how the basic concepts of variables, data types, and operators work together. Remember, the world of programming is vast and ever-evolving, and today's lecture is just the beginning of your journey into this exciting field. Before we finish, I'd like to leave you with a final thought. The power of programming lies not in the complexity of the code, but in the clarity of your thinking. By breaking down problems into small, manageable pieces and understanding the role of each component, you can tackle challenges that once seemed insurmountable. This analytical approach will serve you well, not only in your studies, but throughout your life. Once again, thank you for joining me today. I look forward to our next session where we will further explore the fascinating world of programming. Have a great day, and happy coding!